Wrong button. So V of t is equal to V sub 0 times, this is going to be 1 minus the depreciation to the t power. Where V sub 0 is the cost of the car, or the vehicle. V is going to be its value after T years, and that's where you have to pay attention, because sometimes they're going to throw this dang stuff at you in months, and then you have to come back at it in terms of years. And of course, you have the depreciation. So for us, we have the depreciation is 10% or 0.10. And V sub 0 is 35,000. And by the way, unless it is a specific formula, like something like this, if I gave you something like this, I'd give you the formula. Because I had to look it up. It's not a formula that's very common. You don't see very much. Then I would expect you to be able to use the formula if I gave it to you. So don't worry about having to memorizing a formula. I had to go in the book and look through what in the heck would, there had to be something in there that would help you work this particular problem. So we have that V of t equals 35,000 times 1 minus 0.10 is 0.9 to the t power. So now you give me a time, and I can tell you the value, or you can give me a value, and then I can tell you a time. It says determine the value, so I want to know what V is, of the car 4 years, so that says T is 4, after it's purchased. So they're giving me, it's just a very straightforward, so V of 4 is 35,000 times 0.9 to the 4, and using my handy dandy calculator, so that tells you you're going to need a calculator for the test, even, you know, at least a scientific calculator. And if you have a grapher, that's fine too. Is $22,963.50. So I've lost $10,000. Well, what, $13,000? No, maybe 12. Since I bought it. 4 years later. How long, so now we want T, until the car is worth $10,000. Now they've given us V, so V is going to be 10,000. And this is 10,000. Not used to so many zeros. And this is where I had to look up how your book is working this particular problem. And anyway, so this says that 10,000 is equal to 35,000 times 0.9 to the t, and 10,000 divided by 35,000 equals 0.9 to the t, or 0.9 to the t is 10 over 35. What I ended up having to do, because they don't give you, we don't have logarithms yet, this is what they expect you to do. They expect you to kind of figure it out on your calculator and hope for the best. So that I used on my calculator, and this is, by the way, approximately 0.285. I want to know when 0.9 to the t is approximately 0.285. Now we know it is a number bigger than 4 because it's 22,000. On your graphers in particular, and this is why I couldn't give this particular well, when I'm finished, by the way, with chapter 5, I can give this problem on a test. But at this point, you don't have, the only tool you have, and they expect that you're using, is your calculator. If you look above graph, you're going to see the word table. Now you can do some guesstimates, right? What you could do is say, I know that it is 0.9, it's bigger than 0.9 to the 4. You can say, well, okay, let's do 0.9 to the 10 and see what I get. It's still bigger than 0.28. Well, what does that mean? That means it's bigger than 10. It's stupid that you have to do this. 0.9 to the 11. I'm getting warmer because I'm looking at 0.285. 0.9 to the 12. Just a little bit too big. So it looks like it's going to be how many years approximately? It's about 11 and smidgen, right? That's what you got to do because you don't have the tool in your toolbox, and essentially you're not using the graphers. What I ended up doing is, for those of you with graphers, is I went under the Y equal menu. Oh, got a lot of stuff in there. And it looks like that's from, who knows what it's from. I was torturing somebody with. And 0.9 to the x power. Then I went to above window, there's this thing called table set. And it says, where do I want to do? I want to start at 1, and I want to increment by 1. And I want it to generate it automatically. And now when I do second table, it'll give me a table starting at 1, and I can go down and notice, sorry. Thank you. Well, I did that, didn't I? To the x, because the numbers didn't look right. Whoops, I didn't want to do that either. Second table. I got to stop that. Second. If you want to stop it from doing anything, just hit the on button. That's kind of like the escape button. It stops the processing, because this is a computer. And now you go down and notice that 11 is too big. There you are. It's between 11 and 12 on the table. And that's what they expected you to do, by the way, because this book does do some calculator stuff. But I would just do my best estimate that you can do at this stage. By the time we finish, we'll have an algebra way of doing this problem. But that's what I did, for better or for worse. So I said, using my calculator, I got about 12 years. Or you could say, would 11.5 been wrong? You would have been in Mr. Rogers' neighborhood, right? You're close. And I think it comes out to be 11.9 years, if you want to be exact. Maybe about 12 years. That'd be good enough.